So just a few things. I'm sure everybody else you guys have had has probably told you the same thing, but I'll just give you a few, um, I guess, hints, tips, whatever, to doing all this education stuff online. Make sure you check your emails often, read the entire email, read it twice, just to make sure you don't miss any little details. There's a lot of little details in emails that sometimes get missed. And the other thing is check Canvas often. Um, I mean, those are the two things. Just stay in communication, basically, and don't hesitate to contact your professor if you guys need anything, have questions, whatever. Hopefully this isn't our new normal for the rest of the year, but I mean, at least this semester. But I hope going into the fall we're back to a regular normal. But just kind of keep that in mind. Um, there's Robert. So some basic tips for using Zoom, if you guys haven't yet. Down at the bottom is pretty much everything you'll need to use it. Bottom left is mute and stop your video if you want to just remain on a black screen. It doesn't matter to me. This kind of meeting is just really intro, and will probably be 20-30 minutes, kind of brief. Next week we'll probably have more interaction, just because of the material. This next 3 weeks we're not having a practical exam, but the last grade is that abstract that we're writing. And to be honest with you, last semester was kind of a challenge, even in a normal classroom setting, but I expect to be even a little more challenged this time, kind of trying to do it over the internet and virtually. But there's going to be a lot of kind of statistics and math and things like that I don't know. We'll figure it out. I'm trying to put as much as I can on a PowerPoint to explain the steps, the mathematical steps. But honestly, a lot of it I worked through kind of on the board, and then basically I'll show you how Excel can do it for you quite easily. But honestly, this next this abstract should be an easy A. I'll give you pretty much everything you guys need to turn in. All you have to do is put a few things in your own words and all that. So it shouldn't be too bad, but just like I said, just stay in communication and keep your eye out for quizzes and things like that. I'm going to try and put probably more quizzes than one per week, just to give you guys an opportunity to bring up grades and things like that, since we're not meeting as often as we normally would be. So I'm going to share my screen and go to Google Chrome and show you what's on Canvas, just to kind of touch base with what's on Canvas for this week. I'm going to go over this PowerPoint briefly, but I did put narration to the lecture PowerPoint that I would have given this week under Lab 7. So you've got a narrated PowerPoint, which you should probably have to download. You shouldn't watch it through the browser window. When you just open it, you should open it in the browser window and then download the PowerPoint to your computer. And then there should be well, I'll show you on the next screen, but it should be a little speaker where you can play the narration. I did not time it, so when I'm done speaking, you can spend as much time on that slide reading it, whatever it is you need, and then click to the next slide. So you will have to click through. That way you can spend as much time as you need on the slides. Assuming somebody didn't have PowerPoint, I also put that to a video on YouTube. So you've clicked that, you've got a link to a YouTube video. Pretty much everybody should have PowerPoint, and if you don't, the school does provide it for free. You just go to it.piedmont.edu, but just in case you'd rather have the video on YouTube, I'm playing with my technology and trying to do as much as I can. So just oh no, that's not what I wanted. I want to just go to home. As well, there's a practice quiz on Lab 7, which again is not quite exactly like the quiz. The quiz I'm going to give you for this week is on Canvas, and to get to that, you would go just where you did for the practical, over here to quizzes, and that will be due next week. Next Thursday before midnight. I'm going to give you guys probably a week to do the quizzes. The next quiz might not be that long. It might be do the day of our class, but that day after midnight. This time I gave you a week and an extra day, but just, there it is. So, new share. So the PowerPoint itself kind of looks like, I don't want that. Okay, there's what I wanted. Okay, so you guys see a PowerPoint now, right? Does everybody see? Somebody see PowerPoint? Some thumbs up. I saw. Yeah, Ori. Okay, thank you. All right, so it's kind of a challenge for me sometimes to realize exactly what it is you guys see. So now that I've got this up, I see part of a PowerPoint, and I also have the windows with everybody's camera on the side. But I'm going to minimize that just to hide everybody. So statistics, you guys, again, you'll see this through the narration, but you guys see statistics all the time. And I used to tell my wife that I feel like a lot of statistics can be used to mislead people depending on how it's said. But you guys need to understand what statistics are, what I mean, a median mode, understand what they mean, and what kind of conclusions you can actually draw from that data. And like I said, down here in the bottom right is your speaker. It should play automatically when you're in the presentation mode, which should be this button down here. But if you need to replay, just click on that and you can come up with a little window like that. You can reverse it, pause it, things like that. Now, as far as what you will need to know for that Canvas quiz I just mentioned, it's mostly going to be definitions. So if you know the terms or the definition for all these terms here on this page, you should be good. And all these are bolded somewhere throughout this this PowerPoint. It's only 25 slides, but these two sets up here, the top definitions and the types of histograms, that's basically what you need to know for this set. The next couple of slides, just an example from this textbook that I got this PowerPoint from. The majority of the textbooks out there were business statistics, and I could only find one textbook for engineers and scientists, and that's where this came from. So just kind of, again, to go through these briefly, population is the entire group that you want to know something about. This year's census year, so the population of the census is the entire population of the United States. Now, or even with like an election year, you'll hear things on the news, and so many people are going to vote one way or another. They don't interview the entire population. They interview a sample, which is a small group that ideally is representative of the population. It's not always. There is sample variation, but if you do what's referred to as a simple random sample, ideally that sample is representative of the entire population. So you can draw some inferences about the population from the sample that you have. This italic N is a not really a term, but it's definitely something you want to know. That is the number of values in the sample. So if you have a class of so many people and you measure the height of everyone, N is that number. So not only are the data that you generate from measuring your samples important, but the number of samples is also important as well when it comes to like what we'll do next week with the calculations of the means and things like that. So again, the simple random sampling, it doesn't always reflect what the population is, but great. Internet connection's unstable, so hopefully you guys are still with me. But sometimes you'll have sampling variation. And an example of this would be if you're trying to get, again, an idea of how the entire country is going to vote, but you did your sampling in a very red state or a very blue state, you're going to get sampling variation. Obviously, those types of areas are not very indicative of the entire country. So when you look at data, there's two general types of data you can have, quantitative or qualitative. Quantitative is going to generate a number of some sort, either a measurement or a count, and qualitative is think like qualities. You categorize things and you drop things into different categories. Gender, race, hair color, country of origin, things like that. That's qualitative. It's not really a number associated with it, but it's categories. And I use the term qualitative and quantitative. Just think quantity or quality, um, either or, but numerical and categorical, sometimes you'll see those terms used, but I like quantity and quality. Now, there is no subset of qualitative, but if you look at quantitative, there's two subsets of quantitative. Discrete is a result of counting things, and you're dealing with whole numbers. If you count the number of trees in your backyard or the number of students in a classroom, you're counting whole numbers, okay? There's no sometimes you hear the average family has 2.5 children. Well, obviously no family has half a child. That's just an average. But an average of discrete numbers, you have a set number. So continuous is usually a result of measuring things and does involve fractions and decimals. If you think the desks that we measured, it was, so many meters and so many centimeters. So, 1.2 meters across, that is continuous. So if you just think whether you're counting things or measuring things, you're talking about discrete and continuous. And again, those are both subsets of quantitative values, or quantitative data, where we're generating numbers of some sort. I won't spend a whole lot of time on this, but a controlled experiment is basically where we control the values, or the values and the factors that we're looking at. A lot of scientific experiments are kind of done this way, where you have a control and an experimental set. In observational studies, you see a lot of medical studies, or what they refer to as anecdotal studies, where you kind of look back at the data after the fact, where you can't really control what people eat or things like that, but you can look back and associate certain types of diets with certain types of health, or things like that. The people say a high meat diet will lead to heart disease. Well, it's not like they feed people just meat or just vegetables. They look back after the fact. It's an observational type study, and they usually associate one thing with another. So the mean, you guys probably know, as an average, and it gives an idea of the center of data, that as well as the kind of median and mode in certain aspects. Now, this term standard deviation, just know for right now how standard deviation and variance are related. Standard deviation is the square root of the variance, and the variance is the square of the standard deviation, just kind of that inverse relationship. Both of them really measure how far a set of random numbers spread out from their mean. You probably heard standard deviation. You might hear this bunch of data has a mean of such a number and a standard deviation of a range. But both just know that standard deviation and variance, they both measure how far from that median or that mean this data set is. And again, for how you calculate it, we'll get to that next week. You start off calculating the variance, and then you calculate the standard deviation by taking the square root of that variance. So the mean, your average, I specifically picked this set of numbers 1, 3, 4, 5, and 7 because I knew the mean would be one of those numbers. If you just add them up, you get 20, divide by n, which is the number, again, of data points that you have. So you divide by 5, and you get 4. So sometimes the mean is one of those numbers. Sometimes the mean falls between some of those numbers. Sometimes the mean, if you look at this next set, we've got 50 is a lot larger than all these others. Sometimes an outlier will pull the mean to one side or another from all the numbers. So if you look at the mean, 10.8 is actually bigger than 8, but because 50 is so much higher, it pulls the mean kind of off of what you normally think of as center. So in that case, 50 is our outlier. And outliers, just what they sound like, they lie outside what you think is the normal range of most everything else. And sometimes outliers are real and sometimes they're errors in data. But just, again, kind of know what an outlier is and be able to kind of spot one if they show up. So median, you've got to find, in order to find a median, you have to arrange your data in kind of numerical order from left to right. Okay, and I had already done that with these examples here. You know, when you get your data, they're going to be, you know, all jumbled up. But if you take the data values and arrange them from largest to smallest, and then your median is basically the middle number of that ordered set. Or that is if you have an odd number of values. If you have an even number, there is no middle number. So if n is even, you take the median, or sorry, not the median, the mean between the middle two numbers. So if n is odd, down here we've got 5 data sets. We've got an odd number of values, and in this case the median would be 4. And how you calculate that is, again, the n, the number we have of values, add 1 to that to make that even, divide that by 2, and that number 3, that's the third position. So that number in the third position, which in this case is number 4, that's your median. Okay, when you have an odd number of values. I always can think of median as like the spine of a book. If you're going to fold that number set in half, what number is right in the middle? Well, that's 4. But if you have an even number of values, here we have 6, there is no middle value. Okay, the two closest to the middle is 4 and 7. So you've got the same thing. The mean, you want to calculate the average between the n minus 2 and the n minus 2, or sorry, n divided by 2 and n divided by 2 plus 1 position. So you calculate the mean between position 3 and position 4, which in this case is 4 and 7. All right, you add 4 and 7, divide those by divide those by 2, and you get 5.5. So your median is not always one of the numbers. Again, if you've got a odd number, the median will be one of the numbers, be that middle position. But if you've got an even number of values, sometimes your median is the mean between the middle two. I'm getting another bad internet. I don't know why my internet's running bad today. It's actually kind of nice out at the moment, but and again, the mode is the most frequently occurring. Okay, and sometimes you'll have more than just one mode. And here we've got number 4 occurs 3 times, so that is our mode. And the mode doesn't really always say what the center is. You know, all these median, mode, they're not all really useful by themselves, but when you look at them kind of collectively, sometimes you can get meaningful information out of a set of numbers. And the range is just what it sounds like. It's the difference between the largest and the smallest set, or smallest value in that set. And again, the best thing to do when you see a bunch of numbers is to arrange them like you would be doing the median. Just you know, put them in from left to right and from smallest to largest, and that'll kind of help, at least, you know, starting to analyze that data. So if you look at the dot plot, it is kind of a simple histogram, and it gives you an idea. So here we've got a you know, 4 values at number 51. So whatever it is we're measuring, we have 4 things that measure 51. We have 5 things that measure 76. And 4 things that measure 75, 4 things that measure 80. So if you kind of look at this, it kind of gives you a frequency of your values in a way. So again, a dot plot, it's kind of like I said, a rudimentary histogram. And I'm not going to go through how to create a histogram. You can kind of read this, but I feel like histograms, when you look at it, they're kind of intuitive. So you've got along your x-axis the values that you're looking at, and their ranges. So, and if all this data set, if I've got something that falls between 1 and 3, that's going to be in this column here. Something that falls between 3 and 5, 5 and 7. Obviously, whatever falls between 5 and 7 is the most frequently occurring. Now, the y value can either be raw numbers, or like I have here, relative frequency, which you basically look at as percentages. So Almost 30% of our data fell between 5 and 7. Okay, slightly less than 20% fell between 1 and 3. But again, this can be raw data. This is just a relative frequency. If you think of our dialysis experiment, we calculated percent weight change just to set everything on a same kind of baseline, and that's really what they do here. On our histograms we're going to look at, we're just going to use raw data. So, it could be either or. So when you look at a histogram, if you think, if you have a professor that curves their grade, okay, this is what they ideally want to curve into, is a bell curve. So this is what they refer to as a symmetric histogram, where the right and the left look pretty much the same, and your median and your mean are close to each other, right in the middle. So if you think about this just grade-wise, very few people got low grades over here on the left. Very few people got really, really high grades. Most people did somewhere in the middle. Okay, and that's what you're looking at. The median and the mean. Again, the median would be the middle number in your ordered set. And it's not mentioned, but obviously the mode, the most frequently occurring number, is this one here as well, whatever this category is. So this is a unimodal symmetric, and you can also have skewed histograms. Now these left and right skewed are also unimodal as well. But if it's skewed to the right, that means you have a kind of a tail. The skinny part goes off to the right. And what that does is kind of like the very first data set we had with number 50, it pulls the mean higher than the median. Okay, remember the median is the middle number. So you have a lot of numbers here in this low category, and again, this is your mode as well, whatever falls with this set is the mode. But you've got these really high, and it may be only a few, but you get these really high numbers that pull the mean to one side, and the mean is often higher than your median in a right skewed histogram. And you can have the exact same opposite with a lot of low numbers that pulls the mean to be below the median in this left skewed histogram. So again, your mode is still going to be this tallest column, and again, your median, because you've got a lot of numbers in this tall column, the median is going to be somewhere in the middle. But your mean is pulled below the median by these really, really, really low numbers. Even though there may be only a few, they're so low they pull the mean to be lower than the median. And again, all three of those, left and right skewed and the symmetric, are all what they refer to as unimodal histograms. You've got one mode or one large peak. You can also have what's referred to as a bimodal histogram, where you've got two peaks or two modes. Now, even though one mode, one peak may be less than the other, it's still referred as bimodal. And you can have multimodal as well, which we won't get into, but just know the difference between bimodal and unimodal. And if you're studying populations, like out, my wife studies salamanders, something bimodal usually represents subsamples. But to kind of go to our grading analogy, I always feel like unimodal indicates somebody who, a class who it was either not prepared at all for exam or very well prepared for an exam, where you've got a lot of people who did really well and a lot of people who did really poorly, but nobody really did, kind of in the middle. That'll kind of get us started. Now with next week, and just kind of reminders, you want to get onto Canvas. And again, I don't think everybody's taken a practice. I got Rebecca, Marissa, Robert, and Colby, I think, still need to take the second practical. Remember, it's due tomorrow night by midnight. And again, sometime between now and next Thursday at midnight, the lab 7, and this lab will cover pretty much everything we just talked about with regards to all the terminology that is on the PowerPoint there. And that list will be right here. Okay, just go through and review these terms again, and I think it should be 10 questions. It's really not all that bad, but let's see what else. I really think that's it. Um, I will be putting sometime soon. Look for an announcement. I have a PowerPoint for what we're going to talk about next week. I do want you to review the PowerPoint I put up before we actually meet next week, just so that we're all kind of familiar with it before we actually get together and talk about it, because it was a challenge in class in a real world situation. I expect it to be a little bit more of a challenge. Um, Again, virtual and over the internet. So do try to review that before we actually get together. Um, that's really all I had for you guys today. Again, just make sure you do the practical and the quiz. Um, keep an eye out for your email and what is on Canvas, and I will put some more stuff up there soon. If you guys have any questions, hang out for a few minutes. But if not, I will let you just go ahead and click the end meeting button, and I will see you guys next week.